Well, hey everybody, Mr. Reeves back with you, and we are working on finding circumference and doing some problem solving surrounding finding of circumference. So in our previous video, I worked through and helped you solve problems 1 through 11. So we're going to move on now and look at problems 12 through 19. All right, are you ready? I hope you're ready. Let's dive in. All right, so if we take a look at number 12, it says a dartboard has a circumference of 78.5. What is the diameter? So they give us the circumference and ask us what the diameter is. Remember, in the previous problems, they were giving us the diameter and asking for the circumference. Same thing on 13, they give us the circumference and ask for the diameter. On 14 and 15, they give us the circumference and ask us to find the radius. So what we're going to have to do is figure out how to work backwards. So remember, for a diameter D, we said that the circumference C was equal to pi times the diameter. All right, so let me do this. Let me write circumference. So our circumference is C. So our formula was the circumference is pi times the diameter. All right, and our radius is R, and our formula using the radius for the circumference was pi times 2R because 2r is equal to d. 2 radii added together equal the diameter, or 2 times the radius equals the diameter. So that's what you do if you know the diameter or you know the radius and you want to find the circumference. But what about if we know, like for these problems, we know the circumference and we want to work backwards to find the diameter? Well, let's do a little algebra, all right? So here we go. If my goal is to find out what d is, then I need the d by itself. So I can divide both sides by pi. All right, remember we do inverse operations. The inverse of multiplying is dividing, and I get the formula c divided by pi is equal to d. So if you know the circumference and you divide it by pi, you will get the diameter. All right, we're going to do a similar thing over here. All right, we want to find out what r is. So we're going to divide both sides by pi times 2. All right. So we're going to get the circumference divided by, and I'm going to go ahead and put that 2 in the front because we like having the constant coefficient in front here. Even though pi is not a variable, it is a constant. We kind of throw it on the back like a variable. All right, so the radius is equal to the circumference divided by 2 pi. All right, which should make sense because the radius is half of the diameter, so we have to take our diameter answer and divide it by 2. Do you see how this part here is the same, right? Circumference and pi. Circumference and pi, it's just when with the radius we have that 2, so it gives us half the value. All right, so that is how we're going to do these problems. For these top 2 problems here, for 12 and 13, to get the answer, we're going to do c divided by pi. Let me try this again. C divided by pi is going to give us d. And for 14 and 15, we're going to do c divided by 2 pi is going to give us r. All right, so for 12, and remember we're going to approximate pi by using 3.14. I'm going to do squiggly equal sign to let us know it's approximately equal to. All right, so here we go. So a diameter has a circumference of 78.5. So if I do 78.5 divided by 3.14, that's going to give me my diameter. All right, here instead of 78.5, I would do 166 divided by 3.14. That's going to give me my diameter. All right. For number 14, I'm going to do 47.1, but I'm going to divide it by 2 times 3.14, and that's going to give me my radius. Same thing over here. I'm going to do 10.7 divided by 2 times 3.14. So again, these are very useful formulas that you can use if you need to find the diameter. You take the circumference and divide it by pi, all right? And that's going to be for 12 and 13. And if you need to find the radius, you're going to take the circumference and divide it by 2 pi, and that's what you're going to do for 14 and for 15. All right. Okay, well, what about 16, 17, 18, and 19, Mr. Reeves? What about those problems? All right, well, let's take a look at each of these. 16, the first Ferris wheel designed by George Ferris, thus the name Ferris wheel, was built in 1893 in Paris, France. Did you know that? It had a diameter of 76 meters. About how far would you travel in 8 turns? All right. Well, 1 turn equals the circumference, right? 1 turn, let me try that again. 1 turn equals the circumference. I'm going to run out of space. I'm just going to put a period. All right, so 8 turns is going to be 8c, right? So remember, all right, c is equal to pi times the diameter. Okay, our diameter is 76, so what do we need? We need 8 times pi times 76, and that will give us our answer. How far do we travel in 8 turns? We travel 8 of our circumferences. Okay, so that's what you're going to do on number 16. 17, a 10-speed bicycle tire has a diameter of 26. In the highest gear, the tire rotates 3.4 times per pedal turn. Same idea. How far does it travel? All right, 3.4 times, right? With each pedal turn, 3.4 times the circumference. That's what we need for number 17. And again, circumference is equal to pi times the diameter. All right. Okay, 2 to go. 18 and 19. All right. A can contains 3 tennis balls tightly packed. Each ball has a diameter of 2.5 inches. All right, so it's 2.5 inches across, and it's also 2.5 inches up and down, right? So this one is going to have 3 of those, 2.5, and then 2.5. There we go. All right, 2.5, 2.5, 2.5 times 3. We'll put the little inch marks like they had. All right. How much greater is the circumference than the height of the can? Well, there's the height of the can, right? Right there. That's our height, h, okay? The circumference is going to be the diameter times pi. Well, what's the diameter? That's the diameter. All right, so the diameter is 2.5. How much greater is the circumference of the can than the height of the can? So we need to find the circumference, right? And we need to compare that to the height. And how are we going to compare it? We're going to subtract, right? Find the difference, right? Find the difference between the height and the circumference. The height minus the circumference is equal to, actually it says the circumference is greater, huh? So it's the circumference minus the height is equal to the difference. You actually could just think this one through. If you think about what pi is, right here, pi times diameter is what we usually do. All right, there's 3 of these, and pi is 3.14. Okay, last one, number 19. Two runners are to race a one lap on a circular track. Who ever heard of a circular track? Tracks are not circular. Anyways, the radius to the inside lane is 50 meters. The radius to the outside lane is 51 meters. How much of a head start should the runner on the outside get? He's got to run further, right? So what do we need? All right, we need to know the circumference of the bigger circle and the circumference of the smaller circle. So if we do the circumference of the larger minus the circumference of the smaller, that will give us how much of a head start, because that's going to give us the difference in the distances. So we got to give the guy who's got to run further that much of a head start. And remember, circumference with radius is pi times 2r, because they're giving us the radius, right? These are r's. These are not d's. Okay. All right. So there's how you set them up. I didn't actually do the work for you. I'm going to let you go ahead and do that. All right. So we have this worksheet that we've now gone through where you find the circumference given the diameter, given the radius. We found some perimeters, which included some semicircles and some segments. And finally, we finished up with some problem solving where we had to find the diameter and the radius given the circumference, and then some just good old word problems that we were able to solve using radius, diameter, circumference, all the fun stuff that we've learned. Okay, until next time, have a great day.